So I think you guys started to work on the Coral bot.
Yeah.
Okay. So this is the last update. So if you go on GitHub, so who here, raise your hand if you already used GitHub in the past? Have you ever used GitHub in the past? Okay, cool. So for Ming and for Jacques, if you haven't used GitHub, so just a very quick intro. GitHub is basically a website for coders. And so this is where they typically would share some of the source code. So, and then people could change, other people could join their team and they can change it. And they also can issue some packages. So like a software is like a software package basically, and you have like different versions. You always hear like, oh, I have to update my software, da, 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 da. Basically, these are like releases. And so, so typically you would find that under the code tab here. And also it's really good for tracking issues. So if you're developing technology, whether it's software or hardware, then it's good because you can say, well, I have a problem with this. Can somebody help me? And then somebody will come and say, hey, I can help you. And they can add, you know, a tag here. And they can add labels and they can add milestones. They can say, I have a problem and I need this to be solved by that time. And pull requests, that's one of the coolest functions. Basically, the idea is that you could have people working on the same project in parallel. So let's say you have a software that's working and I have an idea of a feature. And instead of destroying the original app or the software that's working, then I'm going to create a version of my own. I'm going to create my own version of it. And then I'm going to pull it. I'm going to request to pull my own copy of it. So, and if I edit something that other people like, then we might bring it back and merge it into the master. So the master is the main branch. So like this way you could have many people working on the same software and they don't need to destroy the software as they're building it. And then I'm not sure about action actually. Do you know what action is?
Yeah, so I think that action is about some workflow of the CI/CD, which is continuous integration, continuous deployment. It's more in terms of essentially release automation. So I believe that there is obviously different kind of integration workflow that can be added, whether it's Python package, Python, Java, or any kind of language. So this can help to enhance your process, but usually you will think of leveraging those actions when there is something that you want to do, like deploying something or creating a package, something which is fully packaged. So as what we're doing, it's more kind of as a prototype. It won't be capable to connect by itself on the prototype.
Oh, hey,
Felix.
Hi, Felix.
Good to see you. Hello.
But if it becomes very complex,
Cesar.
if it becomes very complex, or if you want to, like something which is server-side, you can put everything which is about continuous testing. So like unit tests, regression tests. So that could be good, for example, if you want to deliver a product or a mobile app or think about, let's say, customer experience, and to make sure that the interface is usable, is just workable. So those are the area that you can enhance it.
Use actions. Cool. Yeah. And then the next tab in GitHub is Wiki. So we use the wiki quite a bit. Oh, sorry, projects. So project is for project management. So here, for example, like if we decide that we want to use the projects, so document version 1. Here we can say, okay, these are the tasks that we want to assign. Let's say I want to create a task and say the goal today is to put the pictures of the last test in the wiki. Okay, so that's a task, and so that's a task to do. And then if we assign somebody to do it, then we can just drag and drop it. And then if you click on it, then you can decide that you can assign somebody, or you can assign a deadline, or you could do you can convert into an issue. So there's a lot of function to it. So it's really great when there's so many things to do. And then we want to make sure that everybody is used to the maximum of their ability. Then we basically issue a lot of issues or create a lot of tasks, and then everybody picks up a task. wiki is the documentation.
Jack started something on that.
Ah, cool.
Huh.
Sensor search. Okay, perfect. So he searched some sensor.
How come we don't see the same thing?
Oh yeah, it doesn't look the same. Okay. And so the wiki enables you to document. I guess he meant he was here probably. Oh,
Yeah.
here you go. So here, maybe Jacques, you want to walk us through like what you found?
Yeah, well, it's nothing much. So just that we had this. Can you hear me well? Can you hear me? Yeah. All right. Cool. So yeah, basically the goal was just to map out the components research. So yeah, because we just want to have environmental survey because pictures are good, but they're not the only factor to take into account, and it can really widen research. So yeah, I just tried to map out a little research of the components we could input in the robots, even though.
So we're going to go back into the detail of it because I think Michael has a. I just walk you through generally the GitHub, and then we go into the detail.
Okay. Sorry.
So here you can basically like document your stuff that you look at, the research.
Thanks.
Security, we don't have to go into it. I really like Insight because you can see who is in the project. So you can see like who is doing what. So you can see like, okay, Maki is inside of it, he's writing. And you can see like who is inside of the team. So you could see who, so the traffic is also like how much people are working on it basically. So you could really see very well like how much people commit, how much people work on the project. So you could see that today, Jacques did a lot of work and you could see it at what time. So yes. And then the last one, settings. Well, so for example, what we love to do is to make sure that all the people who are working on this project, they all join. So that we are all part of it. So I like to manage access. If you don't have a GitHub user, please create one, and at least we'll be able to add you to that team. So if you know your user, you just WhatsApp it to us, and then we add you, and then you can start editing it. So that's it, maybe. So yeah. So what I think is going to be next after Michael presents is that we can decide like what are the tasks. We decide a sort of roadmap, and we can start working.
Okay.
You want this? Up to you.
Okay. That's it here. Okay. Is your WhatsApp here by any chance?
What's up? Yeah.
Yeah. I'll just open that document.
Sure. You want to open your WhatsApp? So it should be. You want to use your phone or my WhatsApp?
No, your WhatsApp. Yeah.
Oh, okay. I already have it open. It should be.
Outside.
No worries.
Yeah.
So it's private platform, then you use developer to share code because we want to be able to manage tags and code.
So this is what I want to. So if you can, sorry, I'm not used to Zoom. If you can share.
Yeah.
Or you'll share your screen.
You already sharing.
Okay, great.
So if you go full screen, everybody will see.
And at any point in time, you can merge a spreadsheet and tag together so you can develop different features. But this is not some kind of code. Like for example, if I want to develop like a CAD model.
Okay, can you guys hear me?
Yeah, can you go full screen?
I'm sorry.
Just click on present. Present, yeah. Perfect.
Okay, can you guys hear me?
Yes.
Yes, I just thought we'd introduce the new people for this evening. So we have Philippe and Adele from last week. Cesar's here, myself, of course, but Felix is new to the group. Ming is new to the group, and Jacques is new to the group. So I just thought you guys could say hello, introduce yourself a little bit.
Yeah, so I can introduce myself now.
Yeah, just hello and.
Okay, I'm Felix. Actually, not specifically coming here because of the show. I'm more interested in like architecture making, And a bit late because I set up a sound installation with Java, which I have to do today because tomorrow is thunderstorm. So it's live streaming at the moment, but it's very dark. Okay.
You are working as an artist, or you?
Yeah, also doing some art projects. I mean, if it's very experimental, I declare it as art, and then I have some other things that I would like to put into products. Also looking for partners there.
It's nice to hear. The drone is going to be beautiful at least.
And sound good.
Of course.
Thanks, Felix. Ming, I just wanted you to say hello to the group.
Hi. Hi, everyone. How's it going? My name is Ming.
So what's up?
Sorry, say it again?
Where are you from?
I'm from Hong Kong. I grew up in Canada. So right now I'm in my makerspace.
This place
right now my school's in Appalachia. Sorry?
Where are you now? The place looks like just like Make a Bang. Are you hiding somewhere like Make a Bang?
Yeah, I'm in my office right now. I'm in my I'm in my school. My school is called the Harbour School, and we're located at Appalachia. And we are a very marine science conscious school. So I hope like this opportunity can like provide like more of an insight of like how these machines are built, and also we're also building it all via ourselves, but like way more basic. Maybe I'll show it to you guys later.
Building what? A VR cell?
Sorry?
I don't understand. What are you building? You're building a VR cell?
Yeah, we're also building our ROV ourselves, but like a lot like ours like we're just using all the basic like we use this the submersible pump, and we convert it into a router.
Very cool.
Yeah. So like, hopefully, I'm just like being part of the team, just to want to learn more from you guys. Hope I can contribute something, but for sure, just learning from all of you.
Sounds good. Thank you.
Thank you.
Maybe you sit here.
No, it's okay. No. Okay. So back to this.
Well, Jack, just say hello to I just want to. I'll introduce Jack's. Oh yeah, Jack, just introduce yourself.
Hi. So yeah, my name is Jack. I'm still a student, and I'm at Maker Bay for 4 months, and in the frame of an internship for my master's. So I'm mostly going to work on the Coral bots, and maybe on some side projects. And I'm French.
Cool. Thanks, Jack. Then I don't know if Matthew and David can hear us.
I can hear you.
Hey, Matthew.
Hi, Matthew. Nice to meet you. Finally.
Finally, nice to meet you too.
Yeah.
You're on my video for a while. Hi, guys. I'm Matthew from the Philippines. I do mostly drones for the air. So flying drones. I mostly focus more on disaster response, disaster rescue, and disaster resiliency using drones. So usually typhoons, earthquakes are my thing. Health crisis, not really. So I'm not doing anything now. So I hope I can contribute my knowledge. Mostly it's all more the post-processing and the mapping side rather than the robotic side.
So just to give more props to Matthew, so Matthew is kind of the OG of makerspaces in Philippines. He started the first makerspace in the Philippines. Okay. And he also started the first, I think, like open source drone company, like flying drones. And now he works in the medical innovation sector. And yeah, Matthew is a one of a kind.
David, are you there?
David.
David's on mute.
Do you want to start the video, David?
Okay, that's what we'll leave David. And
David is maybe a little bit shy. David. Oh, he left. Oh no, he's still there. Oh, hi everyone, nice to meet you. Do you want to introduce yourself, or do you want to be enigmatic? It's completely okay to be enigmatic. Okay, I guess you'll remain Mr. Mystery. That's cool with me. I don't mind. Okay, so so you just go back to your presentation.
Oh, I use Mac. Okay, I think we'll just.
And so here you go save screen,
Okay.
and then you go desktop.
That one.
Sure. Oh, just here. You're very good idea. But then you wouldn't. It's not easy to control. Oh, you can try. Okay. So that's what they see now.
Okay, so I just wanted to flip down.
Yeah, that's the problem. Because you're not on the window, you can control. That's why I think it's better that it's just the full desktop. You just copy the whole desktop, and then what you see is what they see as well. Yeah.
Oh, thanks. Oh, so I'll just show a video that Yui made. Do you want to see this?
Yes.
This is our promo video.
Whoa! It's got music?
Yeah, it should. This is where you guys are. Isn't it cool? There you are, Adele. So that's under construction. I will skip straight down to this week's updates. We got Jack into the team. He's going to be joining us full time. Adele is joining us part time. GitHub, Jack set up the new release, which we already spoke about. We'll be converting all. Cesar started that we'll be migrating all project management to GitHub. We made this CAD model of the aluminium frame, which you can see on the table. And we need to change our name from CoralBot because that's taken. You just watched a DIY drone promo video. Thanks, Dewey. And we've bought a testing pool. So next time you come, we should be testing this drone on the roof in a big pool. And that's the update of this week. And now I thought I would ask Cesar to help me with the problem solving and hands-on stuff that you would like to solve, which I think is documentation.
Right. So I imagine here there's two problems that you display. There's the problem of like uploading a STL file on GitHub and displaying like 3D files. So for example, that's a good example of how would we use GitHub in that context. So for example, here, what Michael lists as a thing that we need to do, 3D display of file on GitHub. So that's the thing to do. And so then you would go on GitHub right there, and you could go on project management, for example, and you just say, well, to document version 1, we need to have a 3D display of the file of GitHub. Okay, that's one task. And then we'll go, okay, the second thing, there's a mechanical issue. The thresholds are clockwise versus counterclockwise issue. Okay, so that's another issue. Here we go, so that's another issue, just right like this. I think another issue I've seen is the antenna is underwater. The antenna is underwater, and that's not good because radio don't go very well underwater. Underwater. What are the other problems that you reckon are?
We need, so Jack has listed some of these in issues.
Okay, issues is also okay. So that's the thing, like you could use it in many different ways. It could also be an issue. Like a bouncy in the back, seaweed netting is constricting water flow, VG-based connection. Okay. So to be frank, I'm not an expert either on GitHub, so I'm not sure what is the best practice. Is it to put on issue or on project? What do you reckon?
For what?
For like tasks. Like say we want to distribute the workload and some people would take like...
You can mark issue as an enhancement, so basically I would put it
you put on issue? Okay, so then I'm just going to delete then from here. Just not to double, just to, I'm just going to remove them.
I think that on this part, you should probably just focus on the work of the week.
Okay.
1 week iteration, because otherwise you're going to quickly be overwhelmed. And if you have to scroll, it's inefficient.
That's right.
The Kanban, it has to be everything in just one view.
In where in projects should just be the week tasks?
Yeah, like over like,
I think so, yeah.
like high view. Okay, makes sense.
Just to see how it's going on, how it's progressed. The problem with the Kanban is just that you see like how much of a work you have for one specific iteration, which will never be more than 2 weeks. So that's the idea.
So maybe do you think
everything
it's,
you put on, otherwise you put everything on the issues, and this issue you can just
do you reckon that in the issue it would be useful to have like mechanical, electric as tags? So these people who are like electric engineer or AI people, they can pick up specific tags. Or let's say like grant writing is going to be like a whole different thing. Or
I use it only for programming projects.
Exactly.
Makes sense. Usually what I do, I have like security tags. I have like enhancement tag, almost classified.
Because right now,
yeah,
these,
you're
yeah.
right. I mean, as long as you're not limited in terms of tags or label, just add whatever. But just try to keep it not too much.
Exactly, not too many. Yeah.
Not over complexify the solution.
I mean, I feel that this project has like 3 or 4 main categories. Like one would be like biology, mechanics, electric electronics, and computer vision / AI.
Yeah.
I feel like if we have those 4 or 5, I think it's a fair.
Someone can pick up an issue anytime and solve it. But the point again is that you may want to use the Kanban part only to highlight which one is a priority. Maybe. That will make sense.
So when you write something in project, does it also show an issue?
No.
Okay, because I thought I saw in project it looks like you could convert things into issue. Let me go back to it because I thought I saw that. So let's say I say create tag. But then I don't want to double create it. I just want to make sure that convert to issue.
Good. Perfect.
And then I want to say, no, I can create a tag. Oh no, create a tag is the word that I put there. Okay. Hello body. Hello nice body. Okay, so that's okay. It's still there, and it should also show in issues. Perfect. Okay, that's cool. But then I was trying to add a label, but I didn't seem to be able to create new labels. Is it possible to create new labels?
I think you can, yeah.
Because you said that you could add security, right? Which is not there.
I've seen it in many products. You should be able to add a label.
So
I can have a look at my GitHub how we do this.
Is there somebody here who is an expert in GitHub? Because if there's somebody more expert than me, I feel I'm not wasting other people's time.
Well, I can have a look.
Yeah. Label issues and pull requests for new contributors. Now GitHub will help potential first-timers contributors discover issues labeled with good first issues. Okay. All right. Maybe I have to look it up. Create label issues.
You have a label, you can just click on it.
I was trying to do that, but I couldn't see the. So if I was on
beside milestone, use it. Yeah.
New issue.
No, the labels.
Oh, okay, sorry. Sorry about that. Labels here.
Yeah.
Oh, okay, maybe new label. Mechanical. Well, mechanical. I think it's fair enough. What do you think is a mechanical color?
Yes.
Whatever. Does this look mechanical to you?
Yes. Oh, that's very mechanical.
That's very mechanical. Okay. Then the other one is going to be saying like electronic. Okay. Then we have AI, computer vision.
I think just put AI.
Yeah, it's okay. Okay.
Again, we need to be too much grammar.
Sure. New label, it would be biology. Biology. There you go. Okay, so now we have our labels. Go back to the issues. All right, so we're going to create a bunch of issues. Oh, did you? I think you also worked on an MVP. Oh, like minimum viable product. I think you drafted something about MVP, didn't you?
The PowerPoint from
Yeah,
months ago.
Yeah. Or because for the new people, they want to understand like what are we trying to do, right? You don't want to read it everything, but you want to at least tell them like what is the thing we're trying to build.
So for me and Felix and the new people, we go missing.
Okay.
So we are designing a coral reef mapping drone, and basically we want to design a remote controlled boat that carries a camera and a computer, a waterproof computer, and this will cruise around by itself with GPS waypoints and take photos of reefs, coral reefs, and stitch all that data, stitch all those photos together, and create maps for scientists to analyze the health of reefs. I think that's a broad outline.
And so do you have like, so you already built this? So the idea, what is the idea with this machine? Because maybe I'll ask like the basic question just to catch them up. So there are RC boats out there. What is this one special? Why do we have to make our own boats?
Well, I suppose RC boats don't have a camera and computer on board. They can take these high resolution photos and then stitch them. The software we want to create is stitching them together so scientists can analyze that properly. On top of that, we want this to be autonomous. So there are RC boats. We want this to be a water drone, an ocean drone that we can set a waypoint mission. So put points on a map on a software called AutoPilot, and then we can send it out for a mission for 4 hours or 3 hours by itself.
So he was mentioning AutoPilot. If you're not familiar, I just will show you how it looks. Basically, you can define an area, say like this, on the software on your computer, and then the machine, the robot, will be programmed and it would execute that route planning. So you basically put this, then you map the area, and then you will get the pictures that you need to actually map the area. Is that clear enough for the newcomers, or is this weird and complicated? Maybe I have this visual. I think that is quite. You basically use this to map. Maybe I will just steal this picture and put them back in here.
So the robot, so it's using GPS.
So you basically program it first. First you program it to say, I want to go there. Then you put the robot in the water, and then the robot will go there. With the GPS, like you said, it will collect many pictures, and after we will stitch the pictures together. So that's essentially the workflow. So it would be plan. See if I make it there. It would be plan the route. Then you'll be sail and take pictures. And it will be assemble pictures. Assemble. And then we use the classifier. Classifier. And then from the classification, we get some statistics. So we want to know. Yeah, is that more clear? Okay.
So on the plan part,
yeah.
The algorithm in which way the robot is going to start to zigzag between inside the polygon with all the waypoint It's something that has to be developed, right?
No, so that's the beauty of this is that AudiPilot is an existing software. So we actually just right now, like this part doesn't need to be developed. So if you use AudiPilot route planning, for example.
But route planning is a waypoint. It goes to one waypoint to another. Here, what you show is different. You draw a polygon.
Exactly.
And then it's do like some trajectory to.
This can be generated by the software. So just
this we have to develop, or the software do it?
This software can do it. But it doesn't do it in an adaptive manner. So what you say, you define the corners, and then you say, I want to be at this height, and my camera angle is this wide, because it would calculate for you how much overlap you have. Because when you take pictures, you want to make sure that you have a lot of overlap. Without overlap, you would have many holes in your map, right? Okay. So after you have defined the area, the map will basically, because it knows the scale, you would say how much overlap you want. So if you say I want to have like 75% overlap, then the mesh is going to be super tight. If you say you just want to have 10% overlap, then the map is going to be, so you can adjust the heights. Okay. So it's very important that you know the width of your angle for your camera, because that's going to be defining how many turns you take. Yeah. So there's also actually the terrain. Also can calculate. You can also calculate it, but you have to be pretty smart because so the waypoint typically is done at a fixed altitude. If you have a very, very uneven terrain, then you would also have to create an uneven route. But that's really tricky. It means like if you want to do something like a 45 degrees, then that means you need to use your reference plane to be 45 degrees. Because if you use GPS, if you stay at the same altitude, you would just crash into the mountain, right? If you want to like map a slope, then
okay, if you I thought, but there's some water, so that's not the issue.
Exactly. Thankfully.
But you have the angle of view for the camera, so it
right.
would be maybe you could maybe let it go more efficient if it's steeper. You can
have more surface
distance.
But then it is more a surface area, but then the quality of the image is going to be less because you're further from the subject, and it probably is much more dark as well.
It's just not the problem.
Now I can only do shallow waters.
Question.
Yeah.
Software is first doesn't understand much about topology, like elevation model, like RGBs or whatever.
It understands, but it doesn't do a 3D render. Typically,
yeah,
it's
you have to tell it to go at this altitude.
Yeah.
It doesn't know that, no, I want it to be 10 meters above wherever you go. This cannot be.
Maybe there's a way to do that. Maybe there's a way to do that.
1 hour to explore, interesting.
Yeah.
And the second point, have you observed any use case where it was actually used not for like a flying drone, but for flying drone? For water, so far, we're the only people that I know that use it for underwater scanning. Actually, it's a really good question. Actually, I don't know anybody who's done that in the water before. A lot of people, I mean, everybody does that for aerial, for flying. But I've never done it. I've never seen anybody. In fact, there's always a takeoff sequence and a landing sequence. In our case, we don't need that because we're already at the right altitude. And is it closed source?
Open source.
It's open source? Okay, so basically we could negative elevation.
Yeah, exactly. And we could change the skin and just say like coral dot, for example. So people could think this is a commercial product. We could reskin it and yeah. So this software is very powerful. So this is really powerful and it's open source. But it doesn't connect to an AI that tells it, oh, there's no features or the water is too dirty, therefore you should go back home.
You only need it for navigation.
Yeah, but this is
need it for the featuring or coral
right.
Analyzing the data science part. It's not required. What do you mean? Because if you want to connect it with an AI, it's to have your robot smart to decide its own way on how to navigate, like avoid obstacle or something. Because
now if you program it and there's a rock, it's just going to go into the rock. Now there's no intelligence at all. This is just you go here, and even if there's a rock in the middle, it doesn't know. Okay, so once you program it, so you have a program. Where does this program reside?
SD card? How do you transfer it to the machine? Is it on an Arduino, a subboard?
So
basically, how this is going to be interpreted by the robot afterwards.
right.
I think is more interesting because if it's just on an Arduino, you can always leverage some kind of interruption to make your bot stop following the waypoint and decide its own action plan if there is an obstacle,
Exactly.
and then come back to the plan. But just need to understand how this plan can be adapted, because I believe that you just push it to the bot and then the bot will just go its own way. There is probably no way that you can dynamically adapt its trajectory after you have programmed it. So tell me if I'm wrong. Or...
Yeah, you're perfectly right. So the way that the waypoint works, it just gives a GPS coordinates and say, now try to go to the next GPS coordinate that I give you. So that's the really basic one. You just say...
It's a list of coordinates.
Exactly. So that's the most basic one.
So basically, if you can interfere with the list while it's being executed,
yes.
At any point you can change the coordinates of you to make it switch direction or change waypoint and come back later to it.
So there's two main modes right now. There's a radio control mode or the autopilot mode. But what you're describing would be like a third mode. Would be like collision avoidance mode, right? Like if there's a rock. Or another mode could be like an AI-driven mode. Let's say if you see there's a lot of coral, because you have some AI on board, then you want to spend more time in that location. So that'd be like another mode. So we have to decide how we want to architecture the software. So ArduPilot allows us to do route planning, basic route planning, or can generate a scanning pattern. But it's not intelligent and it's not adaptive. It's just we're on the beach and then we program it before and it just go.
But again, same as for the collision avoidance. You can always have an interruption. If it detects an interesting area, then it's change mode just to scan the area and then decide the next waypoint, go back to the original program. So that you're sure that you cover the entire surface that you have designed in your polygon in the software. And whenever there is an area, you have more tools scanning around it, more pictures, probably a better definition.
And the problem that we see when we use it is that we drift because so the way it works is, for example, we would say you're gonna go like this, and then the robot is gonna be like, I will try my best, and then it's gonna go, and then the wind is gonna blow the robot like this, and the robot is actually gonna do this, and then it's gonna go like this. If the wind is coming from this way, and then it's gonna arrive here, and it will try to go this way, but it's gonna be like, shit. And it will do like,
Is there any optimization engine to decide which waypoint to go and which trajectory to take depending on the wind?
Not in ArduPilot.
Not Autopilot?
Not in this version of ArduPilot, not that I know. So right now, most of our scan patterns are like super beautiful, like they're like that. But the reality of our route is more like, like that.
Of course, it's different.
Yeah, I have some pictures of like it's like severely drifting. I mean, this can be a problem that we have like further down the line, but yeah.
I think that you probably need some kind of auto calibration of the power to change direction, depending on that GPS deviation that you have while it's moving.
Because the problem with the deviation is that eventually it produces a map that has lots of holes. Do you see what I mean?
But if you cannot rectify the trajectory, it's going to get hole for sure.
Yeah, and we get a lot of holes right now. So, I mean, this is a problem that we're going to experience eventually, but I was hoping I could show you.
That's a collection of pictures from
that's from Udalo. Oh no, this is Hoha. This is Hoha one. This is Hong Kong.
Yeah, nice picture for Hong Kong.
Yeah, but I'm saturating the colors and stuff. Like this is not like in normal state is like this. Yeah, I'm cheating.
I'm kidding.
Yeah, this is like pumping up the colors. Yeah. So I feel that there are different stages of like development. Like one stage is okay, get the ArduPilot to run. Stage number one. Stage number two, add some modes. collision avoidance mode would be like another really cool mode to have. Another one would be like do some AI analysis on the fly, and then you'll be able to focus on one particular coral, but that's further down. So then the question becomes like, okay, what is the final state of the product that we want, and what are the intermediary steps that we need to get to build in order to get there, right? So yeah. So if we want to save the coral, what do you think is how do you guys think we get there?
I think that's probably for me, my first matter is consistency in the way that the robot is gonna perform this scouting to take the picture, because probably that what we did is to monitor over time and use it in many different and use it in many different days on the same area to make sure that the coral listing would help. This is one area that we can explore, and the other use case will be to discover like coral whatever, and that will be totally different. I think that consistency, I just don't care in this situation. I just want it to go there and do the scanning, whatever waypoints I have put. So definitely two different use cases, two different strategies. I believe that if we want it to scout from some area to make sure that the coral is doing well regularly, growing, and try to see over time how it evolves, I want it to be consistent. So always have the same trajectory and do exactly the same thing.
All right, what you say is really important, because what you want to see is the change of coral over time. You want to see like, you're not just going to go there one time. You want to go there in the winter, you want to go there in the summer, you want to see what changed. And so you, like you said, you need to be the same location.
Like the tide may not be the same, so
right.
Basically if I take a picture, the tide is the same, I don't know about the luminosity, or the sediment might not be the same depending on the period of the year. And this will affect your results. I mean, it will give different information.
That's true.
So, so if it's not consistent, I believe it's going to be problematic if you want to do some comparison.
Yeah. So right now, this is where we are. This is where we are now today. We have a radio control boat. We haven't really driven it as an autopilot control boat. Eventually, we want to be able to create a map of coral reef. I want to be able to evaluate the health of the reef. Before that means you need to be able to identify coral. What else?
So this is the priority order.
I'm trying to do like more like a historic order. Like what are the steps to get there?
Okay, so you mean step by step?
Yeah, like a stage.
So your historic order is
stages of development.
Is kind of priority as well.
Yeah,
or it's more like quick wins first.
Yeah, exactly. Yeah.
Oh, okay.
Like what are the steps? Like first, we need to make sure that the motors are moving. Let's say that was the first thing. Number one, it floats. It's waterproof.
Okay.
Yeah. Two, it moves with the radio control.
More with
okay.
It's easy.
Oh yeah, good point. Yes. Then it can be a program. Okay, so what do you think is missing between those things? So now imagine we can float it, we can move it, then we can see things with it. I think there's two seeing. There's one that is seeing in real time, which means that you are there and you can see what's underwater, and the other one you pilot it, but you don't know what's happening. I think it's two different types of seeing. Ideally, you would have a preview, even if it's low res, but just so you know, like, because you could be spending hours, scanning the thing.
But again, you have two different use cases. Either you want a consistent way of doing all the way to scan all the areas,
yes, sir.
Scanner, or either you wanted to discover the area to scan. Someone else?
Cesar, don't forget the battery and how long it would last.
Okay. I can last long time.
Yeah, we need to leverage the current. So whatever current is available to make it move, to scan the surface, I think we need to have the robot get this input so it can save a bit of its energy. Because we don't need it to go fast, actually.
No, this can.
It's not a diver. A diver will get tired. The diver is with oxygen. It can do the work all night if necessary. So as long as it can drift, it can scan a pretty large band because of the battery. So probably for the brain, we want the brain to think as less as possible to save energy. I don't know how much energy it costs for the machine learning, because usually I do it on the computer. I don't really care about this information, but definitely something that we want to look out and try to benchmark when we have the brain working on board. So I would say that the classification, not real time, not on board, has to be done somewhere else.
Yeah.
However, very basic, the most basic possible contour recognition to find out whether there is some coral could be done to help the bot decide to move in a certain direction if we wanted to discover and understand.
So what you're talking now is super great. On one hand, we assume that we have a hardware development track, and then on the other side, we have like a software development track, isn't it? Because
Yes.
okay. So on one hand, we have the hardware. On the other side, we have the software. And on the software side, what you say is get a lot of pictures of coral. Pictures of.
Is there a quality target that we have to take?
How many images do you need to train an AI for coral? At least a few hundreds.
What about quality?
Yeah, I was about to put quality on the table, because I think it would be amazing to have an AI detecting the high quality coral reefs, which could then be sent as a citizen science and for individuals to identify the species and relevant things on the pictures.
Okay, I think in terms of the quality, there is a design choice we need to make early. And we already discussed that with Michael last time.
Okay.
So do we want to build a Tesla, or do we want to build something like commodity to produce, like a
Products,
which is capable to do the job? Because at this stage, we don't know which level of quality we need for the picture to get a well-trained model. It may be possible that with just like 8 megapixel, we can have enough granularity from the lens to do better than the human eye already.
Yeah.
And it may also be possible that we need much better than that. And this will be more tricky. It may happen also that the picture I just might not be satisfactory if the coral is too deep. We just don't know at this stage. Right. So I would say that if we just want to start first with a prototype and get some proof of concept, right. We don't need to have the iPhone of the camera or the Tesla of the camera. We can start with something and just try to see if it works.
Yeah. And also my understanding is that when you use AI, you need actually a very low resolution image, right? You don't need like a very high quality camera. But for map, you want to have a very good camera. So you could
actually, AI is already super strong to improve images.
Okay.
You provided a movie from the beginning of the 20th century. It's going to change it into 4K.
Well, but it does have a lot of
kind of, but overall,
yeah,
if you see the two movies.
I don't know, it's weird. I think the AI has a problem with understand, like.
Yeah, but we're not asking the AI to create things. Or infer missing information. We're just asking it to recognize shapes better than us and colors and be able to.
Yeah, to identify stuff is okay, yeah. But I don't know it's like science.
Yeah, no, I agree with that. I think that at this stage, my only point is, do we want to build a Tesla, which is going to be very expensive, and few people are going to
have
do it?
depends on what is the budget.
Yeah, but my book is not just about the camera. It's about every single pieces. Do you want the overall Tesla for everything? Or do you want something which anybody can build like that, just follow the protocol, and no need to have the most expensive equipment, and very affordable to be deployed everywhere, and then you have thousands of those bots, instead of just like a few dozen, which are very expensive, that any dive shop will be able to get, to find out which are the great spots for the divers. The government can deploy to try to discover areas that need more protection and decide what will be their rules in terms of protection. I believe probably we should first focus on something that can deploy widely. I'm pretty convinced, according to whatever I've seen on machine image recognition, so efficient compared to the human eye, that I will say that it doesn't need very expensive hardware. Some commodity hardware should be able to do the job.
I mean,
and the model itself, you can only build it in a supervised manner. So that means that you need to feed it, and there need to have some people, diver, free diver, or whatever, that just help to classify what they see in the picture that they took, or that the robot took.
So
strategy,
label the picture here, yeah?
Yeah, it needs to be labeled. And for the labels, well, there is many ways. I mean, we can embed the label within the picture itself through metadata, meta information, train the model, for example, by providing some like toolkit for the diver. We can also decide that the bot take the picture, and then we ask the diver to check whether what the bot found is the right information or is relevant with their own data. I don't know, there is two strategies here. Initially, I would have said that prior to invest too much in terms of energy to embed the camera in the bot, I would have said you just send a diver, he take the picture, he go down, he check, and then he label it, and he provide it to us, because the bot will take the picture from the surface. And then if it happens that the model works well, great. If it doesn't work well, we can think a lot of more things, such as having the camera that goes down, for example, or think to do another bot to be submarine. So again,
yeah, there are many ways to do it. You can also use like a regular camera.
We can separate the payload and the robot, right? So
the idea of having a fleet of cheap commodity bot that everybody can assemble, and at the end, what matters to us,
the quantity.
No, it's the brain. It's the server in the cloud somewhere.
They
will have it. The things run, and if you want to keep some intellectual property or protect it from misuse, whether the misuse will be like exploitation of coral, like they're doing in Mediterranean, for example, that you said coral, red coral. So then you can just keep it somewhere in the cloud, and then you can think in a way where you can monetize for self-funding or whatever. I don't know. I think this is more interesting. You open source the bots, but probably the model behind it that would be used for the mapping, you can provide it like a kind of service. Like Google Earth, Google Earth, Google Maps, that's what they're doing. I mean, they take pictures from NASA or whatever, and then the service that they provide, that adds some more layer on it, like the health, the level, whatever. And this, people are ready to pay for it. You can provide freemium from NGO, and if there is a commercial use that needs to be done, they can pay. It depends on you. Just to keep a bit of room to protect a little bit intellectual property or some other things.
Family, genus, species. Family.
And if you want investors, at some point you need to just not to find necessarily a way to monetize it, but show that you're thinking of it.
So this identification would be with AI.
But the problem is that if you want to do the identification in the bot itself, it's going to consume the battery.
I don't think it's necessary. So you need to train some AI.
Yes. Yes, we need labelized picture, which are taken by the bot or by divers. maybe 100 to start with, and then we'll see if it's enough or not. And what we'll do is you just like segment this data set as features between 2 or 3 groups. So mainly a training group and a testing group. And we will assess the testing group, which will be randomized selection to see whether we find the same result as the levels.
We want to also classify the seaweed because seaweeds are competing with corals.
Yeah, coral, fish, cosmet, seaweed. So I understood that fish was a challenge from top because of the shape of fish, which was very thin from top.
Well, that's according to Philip, huh?
Sorry?
That was according to you that there was problems with.
From my point of view, I mean, the identification of coral is not really an issue. Because, I mean, the health of the coral is an issue, potentially, which is not in where we are, but it could be an issue. But the thing is, you are too high. Yeah, I mean, the health of the coral depends of the seaweed, because there's competition between seaweed and thing. Number of fish, because the fish are working with the coral to be clean. The fish are cleaning the corals and eating the seaweed, for example. The light is very important for the coral. So when there's siltation, for example, we lose in luminosity, and the coral. So the conditions of the health of the coral are ahead of the coral health. Yes. If we try to assess the coral health without assessing the conditions that make the coral, the temperature is important, the acidity is important, the clarity of the water is important, the depth is important, and after the corals are either healthy or not, and there's different corals. There's corals that are living in depth and with less light, etc., and coral are right. So all that is pretty known. But the thing is, when we come on the spot, we have to assess if the situation of the coral are optimal for the health of the coral. And that is measured by a lot of other factors than just assessing the coral itself. So we did a kind of a mistake in the process, I would say. We can just look at the guys and he's dead, but but why is he dead? And it's very important to know what the situations bring him to be dead, rather than saying he's dead or he's alive. So of course that's a constatation, but the conditions that give the coral health are much more important and somehow less technical to solve. So clarity of the water, acidity, temperature, biology of the coral, seaweeds, competitors, etc. All those factors are determining the coral is healthy. So if we have kind of sensors attached to that, I mean, here we have one sensor which makes image, which is good, okay. But I think if the final objective is to assess the health of the coral, we need more sensors to have, according to the seasons, what is the light of the things, what is the cetaceans, what is the acidity, what's temperature, etc., etc., and what's the biology within the coral at this time.
And would you consider the tide as well?
Mm-hmm.
Because I think there is one big challenge, like here in Hong Kong, if you free dive like in summer, it's super hot at the surface, like 30 degrees. And when you go down just a couple of meters, it's freezing.
Yeah, but that's a column. We measure the column water. It's normal that the top. Yeah. So we have to have an assessment of the column water at different seasons, at different situations, etc. We know that at the moment the temperature and whatever, because of course it's hot under, but it's also hotter and lower.
What I mean, I'm looking in the Philippines, which is a bit more concerned. But here in Hong Kong, I mean, there is close to no gradient. I mean, there is a gradient, of course, but it's super hot, and suddenly, you don't know why, you just go a few meters deep, and it's super cold. So it's a big challenge, because if you want to take the temperature, you need to take the heat in the whole column. And this, I think, this is not something that we have think in terms of design, because we have a sensor and everything.
It's why it's important to take the photo, because it's right. I mean, it tells also the currents. And in the Philippines, where we might use it, there's 2 seasons where the currents actually are inverted. So once it goes from west to east, and then 6 months later it goes east to west. So the conditions are changing.
Just about the sensors, a quick add up. Like I'm really up for feedback on the sensors, because we've started to work on it on the wiki of the project, and so we're trying to look for the right sensors, and so first look for the right parameters to monitor, and then second look for the right sensors. For example, for pH, it's a great parameter to look at. However, the thing is that it's really hard to design a good pH sensor.
Can you
addition? So I'm really up if you guys have some feedback on the.
Yeah. So I made you the host. Can you share your screen and walk us through your research and what you have found? So if you go at the bottom, there should be a green button called Share Screen.
Right.
If you press on it, then you can share your screen and you can walk us through what you have done.
Okay.
There should be a green button.
I'm gonna go on my. Yeah, I have it.
You got it? Okay.
I'm going to share this. I'm going to share it on the Word document. It's going to be easier than on the wiki. It's more visible. Can you guys all see what I share?
Yeah. Maybe you can zoom a little bit.
Yeah, for sure. Sorry.
Thank you.
So, well, the title is not interesting. So we've tried to look about battery management system. This is not relevant to what we're talking about, but if you guys want to check it out, it's for your own reference. So for the sensors, we think about taking into account temperature, pH, salinity, oxygen, luminosity, and a sonar in order to measure the depth of the sea of the area we're looking at. So, sorry.
Yeah, turbidity.
Yeah, turbidity could be well, actually it's more or less through luminosity, but I'm gonna add it up. It's indeed a very good suggestion. So they have some integrated solutions online, taking into account all of these, just that the price is around $5,000 US. So maybe if we were Harvard, but we're not, so we're gonna go for low cost. So temperature, it's completely easy for $1, and like it's weatherproof in the beginning. pH is gonna be a big issue. I don't know if you guys want to go into detail into this, but if you want, I can go into details. I'm just gonna, for now, just gonna keep it concise and say it's a big issue. It's hard to get, and very strong technical issues. Salinity, I'll have to look it up. I haven't looked it up yet. Oxygen, it's very expensive, $100. This will be a question. Luminosity is quite easy, $10. $10 for luminosity, and sonar is quite easy too, $4. However, most sonars have a limit of a few meters. This one of 8 meters, and coral reefs go down to 20 meters. It can go down to 70, but more rarely. So most of the time between 0 and 10 and 20. So I'll have to see what we want to get. So yeah, that's pretty much it for the sensors part.
For the limit of 8 meters, I think it's okay for us because we are going to be taking pictures from the surface. We need daylights. Below 10 meters, it's already too dark in general, unless it's red.
Seriously,
cool.
12 meters, there is very little corals. You can't really see it. Below 18 meters, I think I've never seen corals.
Yeah, but we focus on surface. I mean, there are corals up to 400 meters. In Norway, they find corals at 400 meters. Could go even, But then there are so few of them, it doesn't matter for us.
But if you focus your research on image taking,
yes,
I think
this is later.
Yeah, if we do both, would be interesting. The survey we needed for the NPI NPA, went from 5 to I think 20 meters. The one that Raymond did for the NPA, the 20 meters. We have three kind of transact. 1 5 to 10, 10 to 15, or 15 to 20.
So I think we have to make that statement. We focus on shallow.
Yeah, okay.
It's not shallow.
So
First.
we like shallow. By shallow we mean under 10 meters.
6 meters, many meters.
So let's say under 10 meters. Statement 2. Well, these are the goals. Okay, it can be programmed. You can call environmental data.
So we agree that 10 meters will be our targets for, let's say, the V1.
Yeah.
And then after this is being released, we can think of a V2 and try to see what can be.
So basically,
Thank you.
Let's try to set up like achievable target to start with. And
this is.
And then Mariana's quotes, we keep it
later. So I'm going to make this into a Google Doc, so at least everybody can edit it as well. Probably my mom or something like that. Wait a second. Who is this? That's my mom. Maman, je suis en réunion, je peux te rappeler plus tard?
Bonjour Loulou.
Je suis en réunion, je peux te rappeler plus tard?
Bonjour Loulou.
Je raccroche, je vais rappeler plus tard. Maman, mais
it's okay, Lulu.
Lulu. Hi, Lulu.
My mom. Yes, make a bay. Okay, I think if we can agree just on the roadmap already, that'd be super helpful. Okay. Do you guys see my screen? I will share with you. So, well, Coral both for the moment, right? until we find another name. Oh yeah. I'm just going to share with everybody. Yes. Where's everybody?
So you did share the Google Drive, right?
Did we? I'm not sure. Did we?
Say it one more time.
You share the Google Drive.
Yeah.
Okay. Okay. It seems that we have a track which is like the hardware track, we have a software track, and then there's a moment of integration where there's a certain point where we can't go further unless we integrate both. So, so then there's a point where we have to integrate. And unless we integrate, we can't go very deep. So with the hardware, do you guys see, or maybe I'll make it a bit bigger? Okay. Hardware, okay, the statement. First, statement 2, we want to make it affordable. To make it affordable, but good enough for ocean scientists to use.
I suppose you need to make a range of affordable. Like for universities, they wouldn't mind paying 10 grand for something, but I wouldn't say 10 grand is affordable. Would you? Or what? Like what's affordable?
In my mind, is like OpenRV, like 1,000 USD. Okay. But in my mind, under 1,000 USD, it's.
Yeah. My drones before were like $1,500, so maybe we can target that. That's with the camera.
Without the camera, or with the camera?
With the camera.
So 500 USD.
1,500.
Oh, 1,500.
1,500 was Matthew Kua's comment just now.
Okay. You said 1,500 USD, right?
Yeah. And around 500 of that was the camera.
Okay.
And what camera was it? Like,
yeah, what camera did you have actually?
I was using a Micro Four Thirds camera, the Canon EOS M2.
Canon EOS M2.
Oh, Canon EOS? Canon.
Oh, no way. You're in Canon EOS M2?
Yeah.
No. I don't think we need to get.
Wow.
Because you can control that with I forgot the CHMDK or with the flash. right? So you can control it with the flash trigger.
No way. That's awesome.
Yeah, so that's what I used it for, like doing drone mapping before, because it's super useful.
Okay, so I'm just gonna add some notes. Just that's additional. That's very interesting. So is there an SDK or like you control from the Pixel?
Yes, there's SDK, but mostly it's via IR. So you can, there's two choices, either IR or via or the flash. So I usually use the flash, but IR is okay.
There's protocol.
PTP?
This is for
Or the flash. I forget what they call the flash thing.
I used to use some device.
Yeah, but I can definitely support.
But I feel that we're heading for the Tesla one.
Yeah, well,
Because if it's just like to start with building a model, we probably don't need such an expensive asset. I'm pretty sure like you should be able to find an 8 or 12 megapixel camera, which is not too bad in low light conditions.
Yeah,
And the flash, we can just connect it on the side. I don't know. I'm just.
I mean, there are also like more compact cameras that can do all that.
Sure. Yeah.
So this is something that's actually.
Okay. Okay. So let's stay focused. So the goal, focus on shallow waters, less than 1,500. You need to control it from the beach. Station 3 deployable from the beach. From the beach, with an autonomy of at least an autonomy that's going to be superior. I mean, minimum is 1 hour, I would say. Minimum 1 hour. What's your experience, Matthew, in terms of autonomy? Because you're flying, so it's a lot. What's the longest autonomy you actually flew on a like long autonomy drone?
Usually 45 minutes. So, but yeah, 45 minutes, including, but you leave with around 30% battery because you don't want to drain down your battery too much.
I see. And so for us, because we don't need to maintain ourselves against gravity, then we should aim at least for double that, I believe.
Yeah, that should be possible.
Unless you can leverage the drift. And in this case, I remember my longest scuba dive, I was just drifting, but 1 hour and a half, like literally not breathing at all, not moving, I did nothing. I just moved my head to watch. So concerning the deployable autonomy, 90 minutes would be good because I'm pretty much doing nothing. Most of the diver that may use it will deploy it for the same amount of time of the max.
But that's oxygen, not battery.
And you will have to dive during the day, like 1 hour each. So it makes sense. So 90 minutes or 2 hours would be good, unless they have 2 batteries that they want to use it. I'm just trying to think in terms of usability. If it doesn't last for both times they have on the day, might be less sexy for them.
So I think we want people who are non-professional to be able to deploy and collect data, right?
Yeah.
It needs to be easy enough that people who are not like professional could just go on the beach and then, for example, let's say we give the boat to somebody on a beach in Indonesia, to a villager. They don't know how to make the route planning. We can provide them an SD card in which there's already the route planning. So they just need to turn it on, put it in the water, and then go, ideally, right? Because you wanted to make...
I don't know, how do you upload your RG plot when it comes to this mission? RC? Or?
You would have to ask Siddhant or Cesar.
Because if it's something you can like send, I don't know, I don't want to over-engineer this part. I mean, the most simple should be good. But
Robust.
think about usability. The divers, often they're in the boat, and they may change plan. They may decide to go to another place than the one which was initially planned. Because they talk and they call each other to understand about is it good or not good, how is the situation. So if they change and you have programmed the robot before they do the dive, it's useless. It's not going to work at all for them. So on the opposite, some of them, I've seen them with like an iPad, like looking some picture or things. So if they can just like use your interface
That's the case. Actually, the way map,
yeah.
You have your well, for drones above, like drone deploy or something like that. It's just you have a map. You draw your parameters, and you enter your data, and it does the programmation.
So it has to be more agile. Like it show the location, and then just draw the polygon around you. And maybe they want to follow the waypoints for the divers so that they can eventually do this classification at the same time, prepare the label. Why not? I think that's
the waypoint is pretty easy.
Yeah, we should think of the design of those who are going to use it the most.
All right. There's going to be like a replanning by the.
It's pretty easy.
There's a replanning by the scientists, or there's going to be
scientists. You mean the divers?
I'm just trying to imagine like so I showed to Adele a video of I think that was the best drone deploy.
Yeah, drone deploy was
because the drone deploy when you use it, it seems to be so easy. So I don't know if you have seen it, but I think that's kind of the gold standard. Basically, anybody could take it, and without being like a professional pilot, they can do it.
The first step is downloading the Drone Deploy app on your mobile device, creating your free account, and just like that, you've joined Drone Deploy's community of pilots flying thousands of flights every day.
Yes, sir, I'm making an open source version of Drone Deploy, so maybe we can deploy that instead.
So, sorry, what you said? Can you say it again?
I was making something like an open source Drone Deploy. So we can use that instead. I can't remember the software.
Not Autopilot, is it? Autopilot?
No, for the data processing.
Yeah.
So that we can automate also the data processing, like Drone Deploy. Drone Deploy is super unreliable.
Is it?
Yeah, I had 3 drones fly away and crash because of Drone Deploy. So please don't use it.
Right. Yeah. So the concept of Drone Deploy is awesome.
Yeah, the concept, the video, the marketing.
Deploy concept is perfect. In practice, it crashes. Okay. I am sorry, I have to go because I have a call at 9 o'clock. But what I say is that if you can sort of continue to sort of draft the roadmap, then it would be so much easier. So you basically want to go through. You imagine like, okay, we made version 1. So say let's say this is version 1, V1, yay. And then you say you want version 2. So this that's the features basically. That will become a feature list.
I would say for today we give out the task for the week, and then return next week.
Yeah.
How much?
I think another few minutes. Oh, it's up to you. But I do have to go because I have a call at 9. I walk to the NTR but June 1 West.
Because I was also thinking of going to the NTR.
Okay. So then I guess that's it for today. Are you guys here?
Yeah.
So the document is the Google Docs is online. What I would say is the goal maybe for Jack and Michael, who are like really working on the project, they're kind of responsible for this. But if you want to spend a couple more minutes, go on the Google Docs, and you can put some ideas or what you think the version is. The idea is that next week, instead of we agree at the beginning of the session, like, okay, this is version 1, and then we'll break it down into features. And like this, we can decide, okay, I'm going to be looking after that feature. You're going to be looking after that feature. And instead of being like so much of a discussion session, it can be more like a work session. Sounds good?
Great plan. Thank you.
Yeah.
Okay, thanks, Cesar.
Bye-bye.
Bye.
Thank you, everybody.
See you, Jack. Thank
Bye,
you.
everyone. Have a good day.